Type 2 is now the limits of double integral will not be given. So you can clearly see on the screen here it is written type 2 if limits of double integral are not given. Whenever the limits not given, what we have to do it, whatever the equations were given like x equal to a, x equal to b, y equal to f1x, y equal to f2x, generally we have always these four equations, and our aim is to draw these four curves. Generally out of four, two are minimum, two are always straight line. These straight lines actually is for the outer limits. Okay, so region is always bound between the two straight lines, and that straight lines are generally that outer limits, that is x equal to a and x equal to b. So as x equal to a and b, that are the outer limit, but yes, f1x, f2x, but we don't know which is a lower and which is upper, and for that we have to draw the region of integration. So first we'll trace these curves. Say y equal to f1x is this graph, y equal to f1x, y equal to f2x is another graph, so this is the upper side, and here the straight line is by dotted line it is shown, that is x equal to a, and somewhere here it is x equal to b there. Okay, so these are the two straight lines that we have. Just a minute. So here is that this straight line x equal to b. Now how to get the limits? Now the limits mainly depends, there are two possibilities. We can integrate it with respect to x or y depending on the nature of the strip we are taking. So this is a concept of the strip, and that is one of the most important concept to get the limits. So you will observe here the strip is drawn as a vertical. You can draw a single line also here. Okay, so that line is nothing but it is your narrow strip there, and that strip we are drawing parallel to y-axis. When we draw the strip vertical strip or parallel to y-axis, the limits of y are variable. The limits of y are variable. How to get that limits of y then? Just you have to check the lower end of this strip is touching to this curve. Okay, we have to check on which curve the lower end is there, and that equation is nothing but a lower limit. If you observe the upper end of this strip is touching to this curve y equal to f2x, so that becomes our upper limit. Okay, that is our upper limit. So we get lower and upper limit for y, and they are variable limits, and whenever they are variable limits, they are inner limits. They are inner limits. Once we get lower and upper limit here, actually this strip is not fixed. Our aim is to cover the entire region with the help of that strip. Then generally this strip is dragged. First this strip is kept at x equal to a. You will observe this is a minimum point. This is a minimum point of x where the region start. The region start at x equal to a. Okay, at this place. So we have to keep that strip at x equal to a, and just we are dragging it. We have to drag it till it covers the entire region. So obviously when we draw this strip at x equal to a and we'll start dragging it, when we start dragging it, it ends at x equal to b there. So limit of x, outer limits are generally taken as a minimum and maximum value of x over this region. Minimum and maximum value of x over this region. So that about the limits of x. I know I'm definitely agree with that. No, you will not get this in just a single example. When we start a numericals, you will get it becomes more clear. Also, I am going to show you one animation here, so that time it becomes more and more clear. So I will take now horizontal strip. Now let me check what happens if we take horizontal strip. Suppose the strip, my strip is this one. This is my horizontal strip. Where this left hand touches, that become a lower limit. This is the lower end. Okay, this is the lower end, this side, and this side is upper limit. Okay, but whenever the horizontal strip is there, the double integral will have the order, that is f dx dy, because x will have the variable limit now. So let me assume this equation of this curve, already it is y equal to f2x, but suppose y equal to f2x we convert in terms of x. Say x equal to, suppose the equation of this curve in terms of x is x equal to okay, say I will take capital F1y. Okay, and this upper end suppose touching to this curve, x equal to capital F2y. So that becomes the lower and upper limit of x, say f1y to f2y, So that is the limits of x. And now we have to check what is the minimum and maximum value. What is the minimum and maximum value of y over this region? And for that, just you have to check what is a, say, suppose this is the low, this is the extreme straight line that touching to this, or it is a tangent to this curve. It is a tangent to this curve, and at that point, at extreme point here. So this is, let's say, y equal to c. This is the straight line y equal to c there, and there is one more straight line. Let me assume. So suppose this is y equal to d, y is equal to d, and that becomes c to d as a limits of y. So this is a another way of evaluating the same double integral. Either we can evaluate Either we can evaluate with respect to y first or x first. If we want to evaluate, if we want to evaluate with respect to x first, now this is the important thing. If we want to integrate first with respect to x, take a horizontal strip, take a horizontal strip, and just take a left hand and right end, which touching to which equation, which curve there, and that gives you the limits. Later on, we are dragging this strip. Actually, we draw this strip should have the minimum position at y equal to c, and we should drag it parallel to x-axis now, upward side, to cover the entire region. So y equal to c to y equal to d, y equal to c to y equal to d. It covers the entire region. That about dx dy. Okay, so these are the two cases. There are total three cases. First two cases will have the variable limit. The last case, case number 3, which will have all limits as a constant limit. I'm going to show you exactly same thing with animation also. Just a wait, and then you can ask your doubts. I will come to the next slide here. So here you will observe what we discussed in the case 2. So I said we taken that horizontal strip. Suppose there is a horizontal strip and it is touching to the x equal to f1y to x equal to f2y. So that about the limits of y, that is f1y to f2y f dx, and then the outer limits are y equal to c to y equal to d. So that is a case 2. So case 1, vertical strip, case 2, horizontal strip, and case 3, now the constant limits. Now one last and most important thing, the constant limits everywhere indicates our region should be rectangle or square. Okay, you will observe in this case it is a square, it is look like, okay, rectangle or square. So whenever the region of integration is a rectangle or a square, then only we have all limits as a constant. So you'll observe the region is bounded by y is equal to c line. This is why you'll observe these curves are there, boundaries are there. The region R is bounded by x equal to a, x equal to b, y equal to c, y equal to d. Our region is bounded by 4 straight lines here. So this is one of the straight line, y equal to c, another straight line, y is equal to d, x equal to a, and x equal to b. So obviously we can integrate with x first. If you want to keep integration with x first, keep the limits of x inside, say a to b. But if we want to integrate first with respect to y, we should keep the limits of y first, that is c to d. So in this case, actually both strips are possible. For example, if you want to see the limits with a strip, so I will draw this strip. Okay, if I take a horizontal strip, you will observe the lower end. The lower end touches to x equal to a, so that become a lower limit for x. And this upper end touches to the curve x equal to b, so that become upper limit of x. So this is the limit for x, a to b. Okay, and then we have to drag this strip from minimum y equal to c to y equal to d. So c to d will be the outer limit. So that about case 3. So throughout the double integration, you will come across only these 3 cases. Case number 1, you may have all constant limit. Okay, if you have all constant limits, yes, the region of integration is a square or rectangle there. But if we want, if the region is not a rectangle and we want order dy dx, if you want to order dy dx, just we have to take a vertical strip. And if you want the order dx dy, we have to take a horizontal strip. Okay, so that about all the 3 cases of getting the limit from the region of integration. So I will show you one animation now, and then you'll come to know how this region is covered. Okay, the region is covered. So here is just a minute. Okay. So you can see one small animation on GeoGebra which shows this is, suppose this is the region of integration. Let I maximize it and minimize it. You will observe one thing. Now this is a, can you tell me what is the order of this double integral? Okay, that's already there. Huh? What's the order?
dy dx.
dy dx, because vertical strip is there. You will observe vertical strip. So this vertical strip is kept minimum at this point, because you will observe, you may observe that this region start maybe at y equal to -3. Okay, so sorry, x equal to -3. The region may start at x equal to -3 and it ends at maybe x equal to 3 there. Okay, so this will be the limits of x as outer limit. So outer limits of x is -3 to +3, and this bottom, whatever the equation of the bottom curve, so that will be the bottom limit for or lower limit for y, and this is upper limit for y. So some of you may think this is a single curve, and if this is a single curve, we have the same limits for lower and upper. It's not like that. It's not like that. Remember, whenever you have, I will write one equation, but to write the equation, okay, I will take a notation part. Okay. Uh, so you will observe, suppose this equation we have, x square plus y square is equal to a square. Okay, x square plus y square equal to a square. We know that is a circle. That is a circle. But can you tell me what is the value of y above x-axis and value of y below x-axis? Suppose this is the circle that we have. Okay, what is the value of y? What is the value of y at this place and what is the value of y at this place? If you take this vertical strip. Yes, anyone? We have x square plus y square equal to a square. I want the value of y at this place below x-axis and I want the value of y above x-axis. Why so
Sir,
much?
it will be same, but signs will be interchanged.
Very good. So what is that same value? Tell me. But it means not, I'm not asking particular number. I'm asking in terms of function, because yes, this curve is x square plus y square equal to a square. So upper arc, this upper arc is plus square root of, is it a square minus x square? But
Yes, sir.
this side it is a plus. And what about the bottom side? Y equal to minus root of, yes,
a square minus x.
so that become a value, limits for y, that become a limit for y. And say this is a minus a, this is x equal to minus a, and this side is x equal to plus a. So double integral on that circle will become minus a to plus a, and then minus root to the plus root dy dx. Okay, dy dx. I hope it is clear how to get the limits there. And this is exactly similar thing that you have here. You may observe this is just like some ellipse. Okay, it may be, it is not standard ellipse, but you'll observe region starts from here and ends at there, and this is the limits. Now let me check. Suppose strip is horizontal. Now you'll observe horizontal strip. The horizontal strip, the order is a dx dy. Now you'll observe the order is a dx dy. I hope it is clear. This is a dx dy, and here may be the minimum value of y. The minimum value of y may be minus 4.5, and the maximum value may be plus 4.5 there. So that is the outer limit. The outer limits are always a constant. Outer limits are always a constant there. So this is the way actually the entire area is covered. Mainly the strip is drawn and it is a dragged. It is dragged from bottom to the top or left to the right. Is it clear? Now, is there any doubt? Is there any doubt?
No, sir.
No doubt? So can I start example then? It becomes more clear then. In example, you have to draw the strip and you have to find the limits. Okay. So
Yes.
yes, we'll go to the example then. Okay. Just a minute. So So these are the few examples from your old question paper. Okay, so we are going to see these examples one by one only. So we'll take the next slide here. And here is the first example on a type 2. Those who are interested, give the heading type 2 when the limits of double integral are not given. And the important thing, you should able to draw the rough sketch of the region first to get the limits. You will observe our aim is to evaluate double integral over some region R, and that R is nothing but it is a region in the first quadrant, and where x plus y is less than or equal to 1. Okay, so let me first draw the region of integration, then only it becomes more clear. Okay, so take a rough x and y axis so that we can draw these curves. This is suppose say x axis, sorry, y axis. This one is our y axis, and let I say this one is my x axis here. Now tell me which are the three boundaries of our region R? Yes, anyone? The region is in positive quadrant. That is the first thing we are given, positive quadrant. Forget about this 6th, 7th. And region have this inequality, x plus y less than or equal to 1. How to draw the inequality first? Yes, anyone? How to draw the inequality?
First, drawing a line x plus y is
Value of
equal to 1.
Very good. That's a correct answer. So to draw the inequality, we should draw the first equality, that is x plus y equal to 1. And to get this equation x plus y equal to 1, that is a straight line, we require minimum 2 points. So which are the 2 points you are going to take it?
0,1 and 1,0.
Yes, that's a simple one. If you put x equal to 0, y is 1. So say this is my 0, 1, and say this is my 1, 0. When we put x as a 0, we get y as 1 and y as 0, x equal to 1, and we get that straight line here. This is the straight line, say x plus y is equal to 1. So we got straight line x plus y equal to 1, and we are given that this is less than. Now this is a straight line. Actually, this is line x equal to x plus y equal to 1. We want less than or equal to 1. So which side? Origin or non-origin?
Origin.
Correct. So this part you learned in LPP in the or in inequality part there. Okay, that topic you learned in 11th and 12th. Yes, the region is towards origin side, and we should able to highlight that region. But one more thing is given, the region is in positive quadrant only. That means you cannot highlight the entire this side. So it is not unbounded region. The boundaries are, there are three boundaries. The first boundary is x plus y equal to 1. Next boundary is this line. What is the equation of this line? Yes, anyone? What is the equation?
Y equals to 0.
Yes, very good. That's correct. So it's a y equal to 0, and boundary of this one x equal to 0.
X equals to 0.
So this is the step number 1. Step number 1, you should able to draw all the boundaries and decide what is the region that we are given. So we have the region now in front of us. Now choice is our. Whether we are interested to take vertical strip or horizontal strip, that is our own choice, and we can evaluate it. Answer will be the same. So which strip should, yes, yes,
Let's take both the strips. First, we should take the vertical one, then horizontal one, so that
okay, no issue,
it would be more clear to us.
Okay, so if we take vertical strip, say, okay, suppose we take vertical strip, can you observe the limits of y now? Can you tell me? Because why limits of y? Because when vertical strip is there, the order is a dy dx, is it? Okay, so
Yes, sir.
tell me the limits of y then. So integral I will become, it's a double integral. I will take xy dy dx. Now you should tell me the limits of y. Where is the lower end touching?
0.
Y equal to 0. And upper end touching to?
1.
Y equal to, it's not 1. X plus y equal to 1.
It's
Upper
not
end,
touching to 1.
upper end of the strip
Yes,
is
sir, it's touching the line.
line
Yes,
x
sir.
plus y equal to 1. So convert that equation in terms of y then. So what is y equal to? Y is equal to 1 minus x.
1 minus x.
So the limits of y are 0 to 1 minus x. That is the limits of y. That is the end of the limits for y there. So how to get the limits of y? Just check where the lower end touching to which equation. So lower end is touching to y equal to 0 and upper end touching to y equal to 1 minus x. So whenever we find the limits of y, we want the equation in terms of y only. Okay. Now from where to where we should drag this strip? We should drag the strip from minimum value of x to the maximum value of x. So what is that minimum value of x?
0.
0. And
One.
maximum value of x over the region?
1.
0 to 1.
0 to 1, correct. So this one is the case when we get a vertical strip. Okay. Now, yes, do the integration one by one and we get the required answer. Now, this question is just like a type 1 example. We already seen in type 1 how to evaluate the double integral. When we want to integrate with y, x is like a constant and do the integration. So, what is the integration here?
Sir, y square by 2.
Yes, x into y square by 2, limit of y is 0 to 1 minus x dx. Then this 0 to 1 again as it is, x as it is, and you'll observe you will get 1 minus x bracket square. This 1 by 2, yes, you can keep it anywhere. So I'll keep it here, dx. That's one lower. So 1 by 2 is a constant. I will take throughout outside the integral. And here it's a 0 to 1. Let I just, as both are algebraic, it's better to square the bracket. So I will say x square plus 2x plus 1. Is it plus 2x or minus 2x?
Sir, minus.
Minus 2x.
Minus 2x, correct. So this is minus 2x and that is a dx. So two more steps and you will have the answer here. 1 by 2, 0 to 1. Just you take x inside first. X cube minus 2x square plus x dx. Integrate, put upper and lower limit, and you should cross check. You should cross check whether you get this as answer. So remaining two steps, do it your own. First you finish this side. Then as he said that we will check with horizontal strip. Okay. If anyone have doubt in vertical strip, yes, you can ask. This is the region of integration, this triangle. This triangle is a region of integration here because it is a first quadrant and bounded by the lines, or it is less than x plus y equal to. Yes.
Sir, please once repeat the diagram.
Diagram is just you have to first draw x and y axis. Then you have to draw the inequality x plus y less than or equal to 1. To draw the inequality, you learnt in LPP mainly that you should convert the inequality to the equality. So you should draw the line x plus y equal to 1. How to draw the straight line? We require minimum 2 points. So which are that? Just put x equal to 0 and y equal to 0 and you will get the points on coordinate axis. So you get 0, 1, 1, 0. Yes. Yes.
Sir, in every diagram, we should keep x is equal to 0, y is equal to 0.
Not every diagram, only for straight line, na?
Yes, I am telling that only.
Yes, for straight line, obviously, that are simple points. Otherwise, you can put 1 x equal to 1 and then find out y. Choice is yours, na? It is at the end there.
Got the answer.
Got the answer. Very good.
1 by 24.
So can we check this double integral for horizontal strip then? Okay.
Yes, sir.
So for horizontal strip, I will just write the integral. Evaluation, you do it your own. So horizontal strip means you draw something like this. And now you can tell me this is a double, when horizontal strip is there, double integral xy dx dy will be there because this is horizontal strip. Okay. Now you should tell me the limits for x.
Yes.
What will be the limit of x?
So 0 to
0
1.
to
y minus 1.
1 minus y, that's one only. And outer limits? Yes, 1 minus y. Because you will observe the left hand touching to x equal to 0 here and the right hand touching to x equal to 1 minus y. So that gives the limits for x there. And what about the outer limits for y?
0
0 to 1.
0 to 1.
0 to 1. So it is actually exactly symmetric integral, means both have the equal efforts to evaluate. You will observe if you integrate with y, you have to do the same effort, and if you have to integrate with x first, then also you have some same effort. But in some cases, what happens, evaluation with respect to y becomes simple and evaluation with x become difficult, or vice versa, and that time we use that change of order. That is a type 4. Okay, type 4 example, we'll come to that there later on. So right now just you have this example where the order doesn't matter. You can evaluate with x or y, and you have right now the same efforts and the same calculation, similar calculation. Your answer,
Sir,
yes.
in the, when we take horizontal strip, so we will integrate x first, right?
Yes, obviously, correct.
Okay.
When you take horizontal strip, integrate with x first, and that this drag this strip from minimum value of y to maximum value of y. Means you have to drag it parallel to that x-axis only. You have to drag it from y equal to 0 to y equal to 1. So that is outer limits there. Okay, so any example in this first, any doubt in the first example?
No, sir.
No, sir.
No doubt. Okay. So I'll move to the one more question then. Next one.
Yeah, okay.
So here is the question 2. First, draw your diagram and you tell me the limits. Okay, you will tell me the limits. I will not draw the diagram here. You should take your time, draw the rough sketch, and you should tell me the limits by taking either vertical or a horizontal strip. That is also your choice.
Sir,
Yes.
equation limits are
Just 1 minute. I will write. Which strip you have taken?
sir y.
Vertical. Okay.
Yes, sir.
So xy dy dx you want to do. Sorry, dy dx. So what will be the limits for y here? Yes.
सर यहाँ पे सर 0
Hmm?
to x squared by 4a
X square by 4a. Okay. And outer?
और out of 2 0 by 2 upper limit 2a.
0 to 2a. Okay. Now let me check whether he done correct or wrong. So let me check this. So step number 1. Let me take these axis here. So this is my x-axis. This one is my y-axis. And the thing that we are given here, the region is bounded by first of all this parabola x square equal to 4ay. What is the symmetry of this curve about x or y axis?
About
x-axis.
No, x square indicates
y.
About
yes,
y-axis.
yes. So already I told, if even power of x is there, symmetry is about y axis. It is vice versa. So first draw a rough sketch here. So this is rough sketch at the end. So don't think about exact graph there. So this equation is x square equal to 4ay. So that we drawn here.
Yes, sir.
Another, we have to draw x equal to 2a. Now x equal to 2a is parallel to which axis?
Y.
Y-axis.
Y.
Y axis. So let I say this is my x equal to 2a. Why I drawn here? Because yes, obviously there will be some intersection point. How to get intersection point? Just replace this x equal to 2a in this equation. We solve these two equations simultaneously. So if you put x equal to 2a here, we get 4a square equal to 4ay. So what is y? What will be the value of y? A. So x is 2a and y is a. So this point is also important. You should get the point of intersection of the curves by solving them simultaneously. We replace x by 2a here. 4a square equal to 4ay and y becomes a only. So that about. Now what is given? The region is bounded by that parabola and the ordinate x equal to 2a, and x-axis is also given. So region is bounded by x-axis. Okay, region is bounded by x-axis. So
X square equals to 4ay and x equals to 2a.
correct. So X-axis means I will say this is y equal to 0. So there are three boundaries now. One is y equal to 0, x equal to 2a, and this parabola. Okay, so obviously that region, the region that we have is this one, this triangle again. It is similar to the triangle, not exact triangle, because this upper side is not a straight line, it is arc there. So as he said, he taken a vertical strip. Okay, vertical strip. So if you observe, if you take something like this vertical strip, the lower end touching to y equal to 0, but the upper end is bearing on this curve. And what is this equation of this curve? It is y equal to
Y
x
equal to x square by 4a.
4a, correct. So this is upper limit. So y equal to 0 to x square upon 4a, and then you have to check the minimum and maximum value, of this x there. Minimum is 0 and
0.
maximum is a
Maximum is
2a.
2a.
So whatever the limits he given, that's exactly correct. Good, very good. Okay, I hope you get this one. And now the integration, you have to do it. Just integrate it one by one and you should get the final answer as a raised to 4 by 3. A raised to 4 upon 3 there. So let me do the steps. So 0 to 2a as it is. X will be as it is. The integral of y dy is y square by 2. And it is 0 to x square upon 4a dx. Now yes, 0 to 2a, this is x. Then you will observe this, you have to replace y by x square by 4a. So what will be the bracket then? Yes,
X square by 8a.
x raised to 4, na? X
Yes,
square
sir. X raised to 4 by 8a.
no, it is a 4a square, na? 4a square, it is 16a square. 16a square into 2.
Yes, yes, yes.
So you should take care of all these things. 16a square into 2, that is 32a square, is it?
Yes, sir.
So that is the correct
Sir, we
replace.
have to take 32 a square as constant, right? For the second integration.
Uh, when we evaluate the inner integral, then other variable is constant. What you are saying?
32 a square if you take constant,
Yes,
no?
yes, obviously, correct. So that 32a square is a constant, that is correct. So 1 by 32a square is there as it is, that is a constant. And what the integration of integrand here? It is x raised to 5. So x6 by 6, is it? And now the last part is left, simplification and cancellation, and check whether you get that a raised to 4 by 3. We should check that. So that's the final answer here.